All right, welcome. So now that you've gone over the overview of what hypothesis testing is, my goal today is to dive straight in and solve questions. We're going to try 3 questions, and I promise you that by the time we're done with these 3 questions, you're going to find this topic extremely easy, right? We're going to take the steps that we talked about in the last video, from step 1 to step 2, all the way to step 6 and a 7, which is interpretation. And you're going to see that if you understand it, the steps are actually pretty basic, right? So let's dive in, right? Let's start with the first question. All right. So it says that, and let me make this larger, that way you can kind of see it very well. All right. So it says that the waiting time for customers at McBurger restaurant follows a normal distribution, right? So waiting time, as you all know, right? To get into restaurants, sometimes you have to wait and all that stuff. And with a standard deviation of a minute, at a particular location, Warren Road McBurger or McBurger, the quality assurance department sampled 50 customers. So they spoke to 50 customers and they found that the waiting time was 2.75 minutes. So they found that 50 customers said that the waiting time for them was 2.75 minutes. Knowing these things is very helpful, right? First of all, let's start with the first thing that we know. We know that the population standard deviation is 1 minute, right? And then we know that there are 50 customers. So 2 things stand out, right? We know that there's a population standard deviation, and we know that the sample size is more than what? 30. And so we know that we're going to use what? The z-test, right? So those are the 2 things that stand out for us. So we know we're going to solve this using z-test. If the population standard deviation was not given, or a sample standard deviation was given, then we'll use t-test, right? Okay, so now that we know that, right, we can then continue from there. So our next step will now be to go ahead and state the obvious, right? So we're going to say, all right, the population, I'm just going to give it pop to save time. Standard deviation is 1 minute, all right? 1 minute. We also know that the people that were sampled were 50. So those people were sampled. And we also know, we're told that the waiting time, the mean waiting time for 50 customers was 2.75. Since the 2.75 is from the 50 people that were sampled, that tells us that this 2.75 is what? Sample mean, right? Because we got that from the 50 people. So that's 2.75. All right. We're now told that at level of significance of 0.05, okay, so level of significance, well, that's your alpha, right, at 0.05 or 5%. And that says, can we conclude that the mean waiting time is what? Less than 3 minutes. Can we conclude that the mean waiting time is less than 3 minutes? Remember, in hypothesis testing, you're always trying to figure out a claim against what? Remember, we said it's like always against the population parameter. And so this by default makes 3 minutes your population mean, right? Because it's always going to be about the population mean. And so that's 3 minutes. All right, so that's the first thing we want to do. We want to pull out all the variables from the question, right? And we've pulled everything out here, right? Now, once we pulled it out, we can now begin to solve it step by step. So let's start with step 1. Step 1 is saying we should, remember it says you should do your H sub O and H sub A. Now, remember I told you that H sub O can only be greater or equal to, less or equal to, or equal to, while H sub A will be the opposite, right? Less than, greater than, or not equal to, right? Always have this because it helps you. So look at the question. It says, what we're trying to investigate is that we're going to investigate at 5% level of significance. Significance level, yeah. Can we conclude that the mean waiting time is what? Less than 3 minutes. Less than 3 minutes. So it says the mean waiting time is less than 3 minutes. So if it's less than 3 minutes, that means that this question will fall under here, because this is where the less thans are, right? This is less than here. These ones are less than or equal to. This one's about equality. This one about inequality, right? So because the question is asking us for less than 3 minutes, our first setup would be H sub A, right? Our sample, our population mean. And I'm just going to show you how to do it, but this is going to take you time in the exam, so don't do it in the exam. I'll just want to show you where it is. So this is right here, right? It's right there. And then the less than ones are right here. Right? But I'm not encouraging you to do it in the exam, because it's time consuming, right? So I'll just show you an easier way of doing it so that we are all on the same page, right? So like I said, you can do it this way, but it's time consuming. But I just want to show you that it exists, right? So we just knew that, right? Because if you're, remember we said these are opposites, right? So if we're saying less than, then the opposite will be what? Greater or equal to, right? 3 minutes. Right? So by doing this, right, what we've done here is we've created our first step. Now, in the exam, if this is a difficult thing, you can just do the same thing. You can just say population mean is greater than or equal to 3 minutes, right? And then A sub A, you say population mean is less 3 minutes. We're good. So I hope this makes sense, right? Once you have this table, right, this kind of makes everything easy. So that's step one. We've set our stage to move forward, right? We've done step one. All right. Step two says we should say what the level of significance is, but it's given already. See how easy this is? This is our step two, right? And so we've done step two. This is our step one. This is our step two, right? Let me just color them because I love colors. So I'm going to color step one, and I'm going to do step two. See, we're on the roll. All right, let's go to step three. Step three is actually easy. It says what type of test is this? Is it a left tail test, a right tail test, or a two-tail test? You can see we've said, remember, we said that HA, and so this goes back to what we've said at the beginning. If HA has greater than a sign, then it's a right tail test. If it has less than a sign, then it's a left tail test. If it has not equal to sign, then it's a two-tail test. All right? If you look at this, H of A here has a left, right? So it has a left, right? And so because it has a left, this is going to be, it's a less than sign. So it's going to be a left-tailed test. Now, this is important in so many ways in solving our question. So it's very important that we get this step correct, right? All right, so that's step three. See, we're almost done. Step four is to find our test statistic, right? Now, remember, to find our test statistic, because we have two factors in the beginning. Remember at the beginning, I told you there were two factors here. It makes this, you're going to use z-test to find our test stat. And remember, our test stat says it's your sample mean minus your population mean over standard error, which is standard deviation over the square root of what, n, right? So we're going to apply this formula, and the top is the difference in mean, the bottom is the standard error. Now, I'm going to show you two ways of doing it. Some students who are really good in Excel, you can do it in one step. But if you are still kind of learning Excel, you can do it, break it down into three parts. Do the top, do the bottom, and then divide them. So I'm going to show you both ways. And then moving forward, I'll do only one way, but I'll show you both ways so that you can choose which one you're more comfortable with. So let's do the breaking down into three parts first. Okay. So we're going to say, we want to look at difference in mean, right? Difference in mean. And difference in mean, what we're going to just do is we'll do a sample mean minus population mean, right? And the second part is we're going to do our error, right? Okay. And that's just our standard error, right? And so that would be, remember, is the bottom here, right? Standard error is the bottom here. So that's standard deviation divided by the square root of your n, right? And press enter. And then your test stat, right, will now be this value divided by this value. And so you get your answer as 1 minus 1.7677, right? Now, if you're someone who's really good with Excel, you can actually do it in one step. So let me show you another way to do this. Just do equal to, right? You do your sample mean minus your population mean. You want to put them in parentheses so they are separate, right? And then you divide by, you open your parentheses here, do your standard, you do your population standard deviation divided by the square root of 50, right? And this will give you the same result. Let me see if we miss something here. Divided by square root, standard deviation divided by the square root of n. So make sure that we got everything in parentheses. That is in parentheses, and this is in parentheses. Okay, something's missing here. Let's take a quick look again. All right, so we're going to go here and we're going to do sample standard deviation minus this. We're going to close that. We're going to open that. Then we're going to do sample divided by the square root of 50. All right, and this should be correct. All right. So you can see, right? That's one way to do it, right? You can do it, break it down in steps, or you can do it as a single way of doing it. And in both ways, you get your answer for your t-stat, right? That's step 4. Now, step 5, there are 2 ways of doing step 5, right? And I'll show you both ways. You can do it for p-value, which we'll do next. And then you can also do it for as critical value, and I'll show you the 2 of them, right? So let me show you for p-value. For p-value, because it's a left tail test, right, you're going to turn it into the probability. And so remember, right, you're converting your z value into probability. So it's going to be num this value 0, 1. Remember the same thing we did in normal distribution, and then true. So it gives you 0.03855. So now you remember you have to compare this. Remember we said that if your p-value is less than your alpha, you reject is actually less than or equal to. If your p-value is greater than alpha, you do what? You fail to reject is So the same thing here. Remember your alpha is 0.05. So alpha is what? 0.05. So you can see clearly, if you compare the 2 of them, right? You can see clearly that p-value is what? Less than level of significance. We will do what? Reject A sub O. So what we're saying here is, and I want to explain what this rejection of H sub O means. Go back here. Remember our setup? Remember our H sub O said that, and let me fix this. I think we missed something there. We missed putting our population mean. All right. So remember our H sub O said that the population mean is greater or equal to 3 minutes, while H sub A said that population mean is what? Less than 3 minutes. If we reject H sub O, then by default, we're accepting that our population mean is what? Less than 3 minutes. That's what rejecting H sub O means. It means that you don't agree with this. You have enough evidence to disagree with this. And so you're going with the second one, right? So since the p-value is less than the level of significance, we reject H sub O. So now we have to interpret the results. So we now say that we have sufficient evidence at 5% level of significance to conclude. And we're just going to look at what they say here. See, here they're saying, can we conclude that the mean is less than 3 minutes? Well, H sub A says the mean is less than 3 minutes. And that's what we are agreeing with, right? That's the mean waiting time is less than. So you can see that we've used the p-value to solve the question and interpreted the result, which is step 6. So p-value, we now reject H sub O, we interpret the results, we're done, right? But what if you want to use the critical value step? So I want to show you the critical value too. So I'm going to do step 5 again, and I'll show you critical value. So remember, we said that the critical value is like a boundary where it helps you tell whether you're going to reject or fail to reject H sub O, right? And remember, when I walk you through that process, I said that it's important to know a few things before you do critical value. First, you need to know if it's a left or right tail. So we know this is a left tail test, right? Secondly, we need to know the level of significance. And in this case, level of significance is 0.05. The reason why we need to know that is that it helps us to create the boundary that we're going to do, right? And so that way we can say, okay, our critical value is going to be equal to, since it's left here, we don't want to do norm inverse, so we're trying to convert a percentage, right, back into a z value. Remember, your test start is a z value itself. So once we do that, we will now put 0.05, we put 0, and we'll put 1. And so we get our answer as negative 1.6445. Now, let me explain this test start again so that it makes sense to you, because sometimes we get caught into being confused on what t start is. All right. So if you want to understand how the test start is, look at what this is. So in theory, the 3 minutes is going to be, for z value, is going to be 0. So your answer you got for the 2.75 is minus 1.767, right? So it's somewhere here, that's 1.767. So what you're asking is this far enough to reject what this is being said, or is that not far enough? That's the whole essence of this. So what the critical value is saying is, and so let me erase this. The critical value is saying that, you know what? Anything after minus 1.645, we're going to reject. It's a O, because it's too far away. Right? And remember, H sub O stands for this one. This is where H sub O stands for. So Once you now take your test start, which represents your sample, right, which is your 2.75, and we're going to bring it here. And you know our test start gave us what? Minus 1.767. And you can see that's far away. This is going to be here, minus 1.67. This is your test start. And remember, we've said that anything here will be rejected, but anything here we do what? We fail to reject. But you can see that test start falls in the rejection area. So that way we would have to reject it alone. So our decision here, right, is since test start falls, you can say fall to the left of your critical value, or you can say falls in the rejection region. We reject it, right? Any of those languages is correct. So now you reject. Now you now have to interpret the results. Well, I don't have to write that because we already interpreted the results here. So what I've just shown you is that step 5 can be done in 2 ways. You can use a p-value and then get the results here, or you can do a critical value and get your same results. The p-value, the critical value is really better when you have it, when you graph it. You don't have to show me the graph in the exam. You can just do it on a piece of paper and you kind of get it. So whichever method you do, you can see whichever method we did, we rejected A sub O in both methods. So they all give you the same result anyways. You just use which one you feel more comfortable with, right? I hope this was helpful, but I'll do a couple more examples so that you feel more comfortable with, right? Let's look at question 6. Right? I'm going to try another one. And my hope is that by the time I do a couple of this, they will just get simpler for you. So let's look at this one. The homeowner claims that the homeowners claim that the mean speed automobiles travel on the street is greater than 35 miles per hour. That's what the homeowners complain. So, right? Now that's a population, right? Homeowners are all claiming. So a random sample of 100 automobiles has a mean closer to 36 miles per hour and a population standard deviation of 4 miles per hour. So imagine that that's what the homeowners claim, and then you decide to check that out, right? And so you sampled 100 cars driving across in that area, but yours was closer to 36 miles per hour, right? So the question is, do you have enough evidence is there enough evidence to support what the homeowners are saying, right? They claim that it's greater than 35 miles per hour. So 2 things before we begin that we need to look at real quick before we start. First, we're given sample size of more than, and that's really not for that second. Sample size is 30 or more. But more importantly, we're given population standard deviation. So we know we're going to use z-test for our test stats, right? All right, so let's start to break this down. So we know sample size is 100, and we also know that our level of significance is 0.05, right? And we know that our sample mean, right? And remember, that's the mean from the sample. So if you did a random sample of 100 people and you got a mean closer to 36 miles, so that means that it's 36 miles, right? Because that's the mean from the sample. And so our population mean here is 35, right? Is also in the question, right? Because that is another way to kind of know that. All right. And one last thing, our population standard deviation is given as 4 miles. All right. So let's start. right? Let's do our step one. Step one is our H sub O and H sub A. Look at the question, right? It says, is there enough evidence to support the claim of greater than 35 miles per hour, right? Greater than 35 miles per hour. Remember we said that if it's greater or equal to, less or equal to, then it's H sub O. If it's less than, greater than, or not equal to, then it's H sub A. But the question is saying greater than, right? So since the question is saying greater than, we know that this is going to be what? H sub A, right? So we're going to come here and say H sub A, population mean is greater than 35 miles per hour, right? If this is wrong, definitely everything is wrong. And so we don't want that to be the case, right? And so the opposite will be H sub O, right? And that one will be the opposite of that. So it's going to be less than or equal to. So is less than or equal to, right? Because we're just doing this one, right? So since this is the claim, right? This is going to be the opposite. You can see we set them up. H sub O will always be equal to, greater than or equal to, or less or equal to. And now we set this up. The next step now is to find our test, the level of significance. That's given here. So that's step 2. All right. So step 1, step 2, step 3 is to talk about what type of test it is. You can see it has greater than, so it means that it's what? A right-tailed test. Right? So remember, we said that if it has greater than sign, then it's a right-tailed test. Right? So we got that done. All right. See how it's getting easier, right? This is our step 3. Right. So now let's do step 4. Step 4 is now to find our test stats. All right. To find our test stats, remember we can break it down into 3 parts, or we can do it in one motion. Whichever method we do it, we'll still get the answer to be correct. So it's just what is comfortable for you. So let me just keep doing this, so that students can feel comfortable with that. Those who are good in Excel can just do it in one motion. Error, and then test start. All right. So difference in mean means your sample mean minus your population mean. We got that. Standard error will be standard deviation divided by the square root of your sample, right? And then test start just means you divide this by that. Okay, 2.5. So in theory, what this means is, and that's what I want you guys to remember this in terms of what we've done in normal distribution. What this means is, this is where the population mean is. That's where 35 is, basically. So when you did your 100 and you got 36, you are 2.5 standard deviations away, basically. So the question is this far for us to reject what the population or what the homeowners are saying? Is that far enough, or it's not far enough? And that's what we're going to do now. So now that we found our test stat, step 5, we can do 1 or 2 methods. We can do our p-value. Our p-value is going to be equal to norm-inverse. Sorry, the norm distribution. Right? We do our 2.5, we do our 0, we do our 1, we do our 2. But this will give us only for the left side, but this is a right-tail test, right? It's a right-tail test. So we remember, you always do your 1 minus. And so you will get, this is a result you get for p-value. And you can see this is less than your level significance. So since p-value is less than a level significance, we reject interval, which is not difficult, right? I mean, you probably knew you were going to reject it because of just how far this is from what the mean is, right? It's too far. But we can also, then we will now conclude that we now interpret our results, right? So we'll say that we can conclude at 5% level of significance. Right? That we have, because if we are rejecting, so let's go back to what we're doing here. If we are rejecting this, right? So we are agreeing with this, right? So we have, or we conclude that we have some evidence to support the claim that the claim of greater than 35 miles per hour. All right. And this is kind of easy because you can actually see it in here, right? You can see it there. So that's, we're just writing what they've said there. Now, let's say that you want to solve this using critical value. That's fine. Critical value is actually a good way to solve it. Actually, I actually prefer it because it uses Z values. Okay. So to do that, right, you need to know a few things. You need to find out what test you're doing. So we know it's a right tail test. That helps. All right. So that's the first thing we need to do. The next thing is I want to find the level of significance. And the level of significance is 0.05. Now, something you need to know, right? The normal distribution starts from around 0, right, and goes all the way to about 100. So 0.05 means 5%. We can't use 0.05 because it's going to be negative, right? Because nobody moves from negative here to positive here, and it's 0 here. But this is a right tail test, so that means it's this side. So what we're going to do is we're going to find what's the equivalent of 5% to the right side, right? For us to solve this question, we need to find that first, right? And so that's the step we're going to do. So we're going to say, okay, that equivalency will be equal to 1 minus what? 0.05. And that gives us 0.95. So that's the opposite side of that, right? And so now we can now find our critical value to the right side, right? And so to do that, our critical value will now be equal to, same thing, right? You're converting a probability into a Z value. And so inverse probability 0, 1. All right. And so we get 1.645, right? And so what you do is you now draw, right? So it's a right tail. We are saying 1.645, right? This is the critical value. So we're saying that because remember, this is where your mean is. We're saying that if the value falls on the shaded area, we reject A sub O. If it falls here, we fail to reject, right? So let's look at our test stats. Our test stats that we did, we got our answer, right? And it was 2.5. And so it falls somewhere here. So it's going to be 2.5. That's our test stats. So you can see it falls in the rejection area. So that means we reject A sub O. So since the test stats falls, you can say it falls in the rejection area, or you can say it falls to the right of your critical value, whichever way you want to put it. You can see, right? The same answer, the same answer. So any method you use, you will still get the same answer, right? And so in both cases, we're going to include our interpretation, right? If you use that, you have to interpret your results. And so you see both methods give you the same answer. All right. Is it getting better? Is it making more sense? So we did an example where we did a left tail test and solved it for you. We now did a second one, which is a right tail test, and also solved it for you. That way you can have better understanding. What I will do now is I will do one more. And this question is more of a two-tailed test. That way you've got to learn how to do a left-tailed, you've learned to do a right-tailed, and you've learned how to do what a two-tailed, right? So that makes you more comfortable moving forward. So let's look for one that is a two-tailed. Yes, that's a good one. All right. All right. This is a two-tailed test, right? Well, let me not say that. Let's sum it together. So this one, Heinz, that makes your ketchup, right, uses a particular machine to dispense 16 ounces of its ketchup into the containers. So that's what it does. So we know that 16 ounces basically is the population mean. From many years of experience with a particular dispensing machine, Heinz knows the amount of product in each container follows in normal distribution with a mean of 16 ounces and a population standard deviation of 15 ounces. Once you see a population standard deviation given, you know that you're going to solve this using z-test. It's the number one thing you look for, right? Having a sample of 30 or more is number two, but this is the key one. A sample of 50 containers filled last hour reviewed the mean amount was 16.017. So that's from 50. So that's the sample mean, right? So we can start working on this, right? So our first thing is to kind of write down what we know, right? So we know that this is 16.017 ounce, right? We know that the population mean, right, is 16 ounce, right? We know that the sample size is 50. And we also know a couple more things, right? The population mean, standard deviation, sorry, we know is 0.15 ounce, right? So these are the things that we know. And then it asks that, does the evidence suggest that the mean amount dispersed is different from, not is greater than, not is less than, not is greater or equal to, not or less or equal to. So we just said it's different from, right? It now says use a sample of significance level of 0.05, right? And so we're going to do level of significance as 0.05, right? All right. So we're told to do a couple of things here that we need to watch out for. We are told to state the null and alternate hypothesis, give the formula for statistics for test start, write our decision, and all that stuff. But all the things they're asking us are the things we actually do, right? These are things that we usually do when we're solving a question. So it's no big deal, right? All right. So we're going to take it step by step. So step one, we're going to find out what our H sub O is and what our A sub A is. Since it just says different from, we know that we're doing A sub O would be what? Population mean is the same, right? Or is equal to 16 ounce, right? And then A sub A is not equal to. So basically what we're doing is A sub O, the population mean is equal to 16 ounce. That means A sub A is going to be what? Not equal to 16 ounce. Right? That's what we're writing down here. And so step two is right here. You don't have to worry about step two, step three. Remember, when we have this sign, right? Usually it means that you have a two-tailed test. Right? So that's step three. All right. So step four is to now find our test statistic. All right, to find our test statistic, remember, right? It's our sample mean minus our mean over standard deviation over square root of n. So that'll be equal to, and we can do it in several ways, right? Difference in mean over standard error. Test it. All right, so difference in mean will be your sample mean, right, minus your population mean, right? Standard error would be the standard deviation divided by the square root of your size, right? And then this is just going to be this value divided by this. So you can see the test stat is 0.80, right? Straightforward, easy, and straightforward. All right. So now that we found, let me just make this a little bit larger. All right. So now that we found our test stat, we now go to our step 5. And step 5, remember, you can choose whichever method. And by now you should have seen which one you prefer. You prefer using the p-value or you prefer using the critical value, right? You should be able to tell which one works better for you at this point. But let me show you how the p-value works when you have a two-tailed test. It's kind of slightly different. So for this, right, you're going to go ahead and put 0, put 1, right? But you remember, right, the way p-value works is that for two-tailed test, remember, it's p-value times 2, because what it believes is that this is 1 over p, is half of p, and this is half of p. So you multiply by 2. But if you multiply this number by 2, you're going to get 1 point something, which is wrong, right? Because remember, your p-value cannot be more than 1. It's probability. It's more than 1. And so if you had a number like, if this was 0.4, then you multiply by 2 and they have 0.8. But once the number crosses to 0.5, then we do it differently. Because if it becomes 0.51, then we multiply by 2, then you're getting 1 point something, right? We don't want that. So once it crosses from 0.5, like it did with this one, the way we solve it is we say this is equal to 1 minus this. And then what you get, you now multiply by 2. So here, our p-value is 0.422900724, right? But this is greater than your level of significance, right? Because the level of significance is 0.05, right? And so this is greater than 0.05, evidently, right? So because p-value is greater than your level of significance, what do? We fail to reject isable, right? Remember, when your p-value is less than or equal to alpha, you reject isable. When your p-value is greater than alpha, you do what? You fail to reject, which is what happened here. We fail to reject isable. What that means is we don't reject this. We don't have enough evidence to reject this. So that means that this will stay the same, right? And so we're going to come here and say our interpretation. We'll see. We do not have sufficient evidence at 5% level of significance, right, to reject. Remember the claim that, let's go back to the claim. The claim, what I told you is, do you have enough evidence suggests that the mean amount dispensed is different from, so we don't have enough to reject that the mean amount dispensed is different from what? 16 numbers, right? All right. So you can see, right? That means that we're not rejecting this. We don't have enough evidence to reject this. This is not to say that this is correct. It just means that maybe we need to sample more, right? But at this point, we don't have enough evidence to reject what is being said here, right? Now let's try critical value. Maybe critical value will have a different value. It wouldn't, but let's do that. So for critical value, this is a two-tailed test. And we also know that the alpha, the alpha or the level of significance is 0.05. Now, remember, with the two-tailed test, it's a little bit different because what you have is you have this, you have that. Now, if your level of significance is 0.05, then by default, what it means that this place here is 95, right? And if it's 95, then what you're left with is 5%. If you divide that by 2, that means that this place is going to be 2.5%. This is also 2.5%, right? So what that means is that if I want to do my calculation, I'm going to do my calculation based on this, which is 2.5, and this area here, which is 100 minus 2.5, which is 97.5, or 2.5 plus 95, which is 97.5. So I'm dealing with 2.5 area, and I'm also dealing with 97.5%. Those are the areas I'm dealing with, right? Another way to put it is, if you're confused, another way to put it is to say this is equal to this value divided by 2. So then the second, so that's for the first part, which is 2.5, and then for the second part, it's going to be 1 minus what? This value, which is what? 97.5. So those are the two areas they are dealing with. And so we want to find the critical values for these two areas, right? To solve the question. And to do that, we're going to do the same thing, right? We're going to do non-inverse. We're going to do for this value, 0, 1. And then we'll give you the same. I'm just going to drag it. It should work. So you can see it gives me the same. So what's telling me here is the two-tailed will reject ace of O here. We reject ace of O here. We fail to reject ace of O here. And our critical value to the left is negative 1.96. That's our critical value to the left. Our critical value to the right is 1.96. So now, what's our test stats? If you look at our test stat, it told us we were 0.80. And where does 0.80 fall? 0.80 will fall somewhere here, right? Because the mean is going to be somewhere here, right? So 0.80 will fall somewhere here. So you can see it falls in the fail to reject area. So we'll just say, since the test stats falls in the fail to reject region, we fail to reject reasonable. So you can see, right? And then we can have interpretation, we just be down here, right? We just copy the interpretation here, and we just paste it here. You can see, right? This is interesting. You can see using our p-value as well as our critical value, we got the same answer. So it's a matter of choice. You don't have to do the two in the exam. Just choose one that you feel comfortable with and use that. And you can see that they will give you the same answer. I hope this video was helpful in making you understand this topic better. The next video you're going to watch is how do you solve hypothesis testing when you have small numbers, but most importantly, when the population standard deviation is not given. How do you solve that? And that's when you use t-test. And we're going to use t-stat and t-stat, t-test. It gets a little bit confusing, but once you understand it, it's actually pretty easy. So I would just say t values, t as a table. So we'll use the two of them, and you will see the difference when we are working with t values compared to z values. I do hope this video was very helpful. For extra credits for today's class, I wanted you to get a chance to get some extra credits. Right? So those of you watching this video, you need to do 2 questions. Right? We need to do actually 3. Question 2, and then 9, and then 11. So let me explain that again. So question, write down, question 2, 9, and 11 are going to be your extra credit questions. And so if you do that and submit that by Saturday this week, you will get credit for that. All right. Thank you for watching, and I hope this was helpful. If you have any questions, feel free to reach out to me via email, or you can send me a message on Google Chat, or come to office hours, right? And I'll be happy to help explain this in more detail. All right. Have a great day.